Hello everyone, I'd like to welcome you to our general chemistry lab once again. This time the topic of our discussion is the continuation of the titration experiment. Specifically, we're talking about vinegar analysis. So I'd like to remind you what we had to look at the previous week. We looked at finding exact concentration of sodium hydroxide solution with the goal of finding its exact concentration. Just a reminder, such process in chemistry is referred to as standardization. So we titrated a primary acid, or KHP, potassium hydrogen phthalate, with an AOH, and as a result we gave you data. Hopefully you were able to find exact concentration of sodium hydroxide. So if you were in the lab here, you would have titrated KHP with an AOH, you would have found the exact concentration of an AOH. You would then would have kept some of that solution of sodium hydroxide in your drawer, and this week you would use it to look at vinegar. And so we begin our discussion by talking about what vinegar really is. A lot of times people get confused and they think that vinegar is the same thing as acetic acid. It is not. Acetic acid is actually vinegar is a weak solution of acetic acid in water. There's a huge difference between vinegar and acetic acid in that vinegar can be safely used in preparing foods and consuming it in small quantities, while if you took acetic acid pure and consumed it by accident, for example, there would be extremely severe health consequences because it would literally burn the intestines. So I'd like to remind you not to confuse acetic acid with vinegar. And so here we're going to use our standard solution of sodium hydroxide to determine mass percent of acetic acid in vinegar. Moreover, we're going to actually look at comparison between two different brands of vinegar, national brand like Heinz versus store brand like Kroger. So the question is, obviously, store brands are always cheaper than comparable national brand products. So here we're asking a question, is there a significant difference in mass percent vinegar between the national brand and the store brand? So the idea is to take known mass of vinegar, titrate it with the standard solution of an AOH. I'm reminding you again, this sodium hydroxide is considered standard because its concentration is known exactly to 4 digits after the decimal. The titration is accomplished in the presence of phenolphthalein. I will post some videos of the actual procedure. It's very similar to last week's procedure. Once again, acid, in this case vinegar, is in the flask. When you add phenolphthalein to it, it remains colorless because phenolphthalein is colorless and acid. And then you add sodium hydroxide from the burette until very light pink color is achieved. Here is the chemical equation of the reaction that's expected to occur. So acetic acid and vinegar is going to react with sodium hydroxide, producing sodium acetate and water. It's another example of so-called neutralization reaction, where acid and the base react to produce salt and water. As you can see from this equation, the acid and base react in 1-to-1 molar ratio. It's very, very important because the assumption here is we're going to be adding sodium hydroxide to the vinegar in the flask from the burette until so-called equivalence point is reached. So what do we mean by the term equivalence point? Well, what we mean is that we assume that the amount of sodium hydroxide added in moles is exactly equal to moles of acetic acid present in vinegar. In other words, we don't add any excess of base. And at that point, the solution is very, very lightly basic, which manifests itself in the light pink color. So what I'd like to do is explain to you how you're going to fill out your report sheet. Your report sheet on page 147, and it also actually continues on to page 148. So you will be given some data, I'll explain which, and then you're going to complete calculations necessary to find percent by mass of acetic acid and vinegar. So first thing under part A, it says preparation of a vinegar sample. So first thing you have to do before getting to part B, before getting to the big table, you're asked to figure out how many milliliters of vinegar is needed for titration. It says calculate the approximate volume of the vinegar sample needed for analysis. So here we need to make some assumptions. First assumption we're going to make is concentration of sodium hydroxide is roughly 0.1 molar. Here, just 0.1 molar is fine because you're doing a rough estimate. And then we're also going to assume that it's going to take right around 25 milliliters of sodium hydroxide to complete the titration and to bring the solution to the equivalence point. So having molar concentration and volume, you can find moles of an AOH. I'd like to remind you though that volume here is given in milliliters, so you have to remember to convert it to liters first. And then you're going to multiply volume by molar concentration, and it will give you moles of an AOH. And then from moles of an AOH, you're going to make a transition to moles of acetic acid. Now, how do we find moles of acetic acid from moles of an AOH? Well, just like I already mentioned here, we're assuming titration is done to equivalence point, and at equivalence point, moles of acetic acid and moles of an AOH are equal. So essentially, moles of acetic acid and moles of an AOH here is the same numerical value. From moles of acetic acid, then, you can find mass of acetic acid. Molar mass, I believe, is provided in the write-up for acetic acid, so knowing moles and molar mass, you should be able to find mass in grams. And then from mass of acetic acid, you need to make a transition to mass of vinegar. So question is, how can we do that? Well, we have to make another assumption. And another assumption we're making here is that we're going to assume that mass percent of acetic acid in vinegar is equal to roughly 5%. Of course, from data provided, you'll be able to find that mass percent more accurately. But how do we find mass percent? Well, mass percent is typically found as grams of the component of interest. In our case, it's acetic acid, divided by total mass of mixture or solution. In our case, that solution is vinegar. So assuming that mass percent of acetic acid in vinegar is about 5%, grams of vinegar can be found as grams of acetic acid found up here, divided by 0.05. Why 0.05? Well, because 5% divided by 100 is about 0.05. So you're going to find grams of vinegar here, and then the last step is to go from mass of vinegar in grams to its volume. Remember, we need to find out volume, not mass. So how do we convert mass of substance to its volume? Well, we need to know density. Another assumption we're making here, which is a fair assumption, of course, is that because vinegar is 95% water, we can assume that its density is equal to that of water, 1.0 grams per milliliter. So that allows you to finally find volume of vinegar that is needed for the titration. So now let's go ahead and discuss how you're going to fill out your report sheet on pages 147, 148. So I will provide data. You will be given mass of vinegar. It's number 3 on your report sheet. And then for part B, you will be provided with initial burette reading and final burette reading. And then, of course, for number 3, for volume of an AOH used, you can find it by using final minus initial for volume of an AOH. Now, for number 4 in part B, it says molar concentration of an AOH. Here, I would like you to use molarity of sodium hydroxide that you found in last week's report, which you should still have, of course, which you probably scanned or photographed and submitted for grading, but you should still have the original. And that molarity of an AOH that you found for the average of 3 titrations with the data I provided to you must be found to 4 digits after the decimal. So something like 0.1234. So you should have 4 digits after the decimal here for molarity of an AOH. So you're going to take that molarity you found last time for the last week's report, and you're going to copy it into number 4 in part B for this week's report. And then for number 5, because you will have exact molarity of sodium hydroxide and you will be given volume of an AOH, you can multiply molar concentration, this of course is in moles per liter, times volume of an AOH used for titration, which should be in liters, remember to convert, and that will give you moles of an AOH. From that point, once again, assuming the titration was done to equivalence point, if you know moles of an AOH, you can find moles of acetic acid, which is the next entry on your report sheet under number 6. And then once you have moles of acetic acid, you're going to use its molar mass to find its grams, and finally mass percent under number 8. I'd like to point out also that on the bottom of page 147, it says calculations for trial 1 of the first vinegar sample. And on the next page, there is some room provided. So be sure to show those calculations in detail, how units are canceled. Remember what we talked about in terms of significant figures as well. And then it says discuss briefly a comparison of the 2 vinegars. Or for analysis of a single vinegar, calculate the standard deviation. Because we are going to give you data for the 2 vinegars, I would just like you to briefly compare mass percentages of acetic acid in the national brand, Heinz versus store brand, Kroger, and tell me whether you think they're close enough or maybe there is a big difference. So hopefully this Prelab lecture will help you with filling out the report sheet. Should you have any questions about how to do all this work, please don't hesitate to email either me or your TA. Thank you for your attention.